Hi guys, so here we are. So there up you can see some series that are organized so that we can just solve. We are done with this series, with this first series, 1, 2, 3. Okay, and now we are going to do this 3 also. Then if there is a little bit of time, we will finish also with this series. Okay, with this series and this one for 2020. Okay, we are going to solve this for 2020. And also this one for 2019. Okay, this is the first, this is the second, this is the third, and here they ask us to find the sum. Okay, it's like they gave us the number, so you have just to find the sum. Okay, bit by bit we are filling the basket. So for this for this series that we can see here, okay, first we have this one. So whenever we have a series like this, okay, that it is a like this one organized in this way, we have a polynomial minus a second polynomial. So the best way to use, so the best option to use it is partial sum, because this is always in partial sum, as you can see like this one. So just apply partial sum for this and you will find your limit, your convergency, the convergency of the test. So surely you can also use other different tests, okay? Surely you can use different tests, okay? But I wanted to use partial sum, even by what's the name of that one? Okay. So you can try, okay? Just try. Now let's go. So it is already arranged in a partial sum way. So what do we have to do? So it means that okay, by partial sum. Okay, do just this one. So this is root n plus 1 minus root n. So from 1 to infinite. See, all we have to do is just start substituting. For n equal to 1, this will be root 1 plus 1 minus root 1 plus, for the second, this will be root 2 plus 1 minus root 2. Okay, so in this way we can just keep it up. Plus 3 terms are enough to understand the behavior of this sum. Okay, 3 terms, first, second, third. Then what we have, root 3 plus 1 minus root 3. So here what you get, this is plus finite. Here it will be root 2 minus root 1, okay, plus root 3 minus root 2 plus root 4, it is 2 minus root 3. And if I continue, this guy will be annihilated also. Okay, so in this way, just see, in this way you can see that this one is going to be cancelled with this one will be cancelled with this, so I will remain only with a term here, see, with minus 1 and this 2. Okay, so what does it mean? It means that this one will be constant, will be always there, and the first series that we have here, this one, will be also there, constant. We have just to pick up this and this one, the remaining term. Okay, so it will be what, root of n plus 1, okay, minus root of 1 negative, this is 1. Okay, it means that if I sum all the terms here, it will be equal to this one. Okay, it will be equal to this one. So now that we have found that this sum is equal to this one, we have to find the limit, okay, for this sum, the limit for the sum, for the partial sum of this guy. So just come here, this is the n goes to 1 to infinite. You have to find the limit of this guy. This is root n plus 1, root plus 1 minus root n. So what is the limit of this guy? So we know that this one is all equal to root square root of n plus 1 minus 1. Then it will be limit n goes to infinite of root n plus 1 minus 1. Okay, then just solve this one though. So if you substitute here infinite, it will be root of infinite plus 1 minus 1. All of this will be infinite. Then it is divergent. Okay, just like this, because we know whenever the sum, okay, of a series, whenever this a series, okay, has a finite number or is equal to a finite number, so the series converge. But whenever a series, the sum of all the terms of a sequence is infinite, so this series diverge. Nice. Let's go for the next then. The next is okay, we have sum. Okay, we have sum and goes from 1 to infinite of 2 to the power n and n cubed plus 1. Okay, just like this. As I told you, so whenever you see power and polynomial, just go straight. Use okay, here we use ratio test. Okay, what will it be? Limit of u dn plus 1 upon un must be equal to the same guy. Okay, what is u dn plus 1? Here where you find n, put n plus 1. N plus 1 upon n plus 1 cube plus 1. Okay, then divided by 2 to the power n, and here n cube plus 1. What you get here, this will be limit where n goes to infinite to the power n 2 upon n plus 1 cube plus 1 multiplied. Okay, here it will go up. Okay, we'll get this one, n cube plus 1 then to n. Now just do this one, this cancel with this one. Okay, just cancel out. You get limit of 2 n cube plus 1, and here you get also this n plus 1 cube plus 1. So if you see this well, what you will end with, so here just pick up, okay, this is equal to limit n goes to infinite. Here just pick up the greater n with the greater exponent here. It is n cube, 2n cube. Put here 2n cube. And here just pick up also n with the greater exponent. When you expand this n plus 1 cube, you will end with 1n with has greater exponent. This will be n to the power cube, or n raised to cube, or raised to 3. This will be n cube here. Here the greater n, the n with greater exponent here will be n to the power 3, and here 2n to the power 3. Just this guy and this guy canceled out. This guy will be equal to 2. So in the ratio test, whenever the limit is greater than 1, so we say by ratio test this series diverge. This series diverge. Okay, it's done. Now let's go for the third now. Okay, the third exercise is, yeah, this is this one. So 1, and we have 2 raised to n plus 5 upon 3 raised to n. So this one is very easy. Okay, this is here you can just directly divide these two. Okay, split this one. Okay, because sum of if I have, okay, series, sum of the series is series of the sum. Yeah, it's just like this. 2 by 3 to the power n plus this is another series 1, and this 5 can be out, and here I've got 1 by 3 raised to n. Now see this series here, okay, and this series here, as you can see, this is both this and this is a geometric series, okay, and here we can apply geometric series. Why? Because very simple. Why? Okay, because we have a term like this one, and this is equal to the, how can I say, general term an for a geometric series. An it's equal to a1 time r, the ratio n to the power minus 1. Okay, so this is similar to this one, okay, but if you see this one, this is similar, so you will just compare this r and with this term here. That's why here it is a geometric series, because here r will be 2 by 3. Okay, the term that has that is resting to n will inside it is what we call this the ratio of this one. Okay, so first we have to do, what is this? Okay, this series down 2 upon 3 the power n is a geometric series with ratio. What's the ratio? 2 by 3. And 2 by 3, okay, 2 by 3 is the ratio, okay, is less than 1. So we know that whenever, okay, the ratio of a geometric series is less than 1, so this geometric series converge. Okay, yeah, therefore it is convergent. And it converges to what? It means that if I sum all the terms here between 2 by 3 the power n will be equal to the first term upon 1 minus ratio, and this will be equal to what? Just the first term, put here n equal to 1, then you get 2 by 3 2 by 3 2 by 3 1 minus 2 by 3, that is the ratio. Then just solve this one. This will be easy. Okay, 1 by 3, 1 by 3, this will be 2 only. Do the same for the second remaining term. Okay, 1 by 3. Okay, here you can just use also this 5 here, there. Okay, so the initiate, you just repeat everything you said here. It is this series is a geometric series. Okay, with ratio. What is the ratio? Okay, ratio r is equal to 1 by 3. Okay, and it is less than 1. If ratio is less than 1, what we can say? Therefore it is convergent. This conversion, and okay, this will converge to a number. Which number is this? By 3. This 5. This will be 5 time, okay, 5 time what? Time the will be a1 upon 1 minus r. 5. What is a1? A1, just put here 1, will be 1 by 3. And here 1 minus 1 by 3, that is the ratio. Just solve for this one. This will be 3, here will remain 2. It will be 1 by 2, then 5 by 2. So what we can say about this this series, okay, I mean the total series, this series, okay, converge. Okay, this series converge. Okay, this series converge. and it converges to, then just sum all of this and this, okay? It converges to 2 to the power n plus 5 upon 3 to the power n, okay? Infinite goes to 1. This converges to what? This will be 2 plus 5 by 2. Just add this one, the convergence number that it is going to converge will be 9 by 2. It means that here, if I sum all the terms here, if I sum all the terms, okay, n term, I sum all of them, it will be only equal to 9 by 2, okay? If I sum all of this term here. It's okay. Thank you very much. Hope see you in the next video.